Kinematics Test question 1, and we're asked to draw a velocity time graph. Important thing to remember at A level is all graphs are sketches, and you should use a ruler, which I don't have the ability to do in this app. So a car's travelling at 10, accelerates, reaches a speed of 30, travels at a constant speed, and then decelerates. And we have key points when it comes to time. And what we know is that travels at the constant speed for 5 seconds and it decelerates for time. Now it doesn't matter on my graph that 10 is shorter than 5. So long as I've marked it as 10 and 5, the examiner will give me the marks. Now note this graph is being asked before you're asked to find the time taken for the car to accelerate. They're not looking for this time here. Look at how I've labelled the horizontal axes. I've used arrows to show the time. The other way to label the horizontal axes would have been to say that this happens at time t. Well, 5 seconds later would be t plus 5, and 10 seconds from that would be t plus 15. Either of these would be acceptable. So the car starts at 10, finishes at 30, and its acceleration is 5. So we're going to use v equals u plus at. 30 equals 10 plus 5t. 30 take away 10 gives me 20, which is 5t. So t would be 4. And I'm not going back to mark that on the diagram. We weren't asked for that. What I am going to do now is draw a new diagram to help me with part 3, which is to find distance travelled. And the important thing to tell the examiner first of all is that the distance is equal to the area. And in this case I'm going to split my diagram into 2 trapeziums. The area of a trapezium is half the sum of the parallel sides times the distance between them. So for number 1 that will be a half of 10 plus 30 times 4, so that is 80. For number 2, the length of this side is 15, the length of this side is 5, so half the sum of the parallel sides times the distance between gives me 300, so the total distance travelled is 380. Now not everyone likes working with trapeziums, so you might decide to split the shape up slightly differently. You might decide to use the equations of motion. You've got to tell the examiner what you're doing, and you've got to tell them which section you're working with. Question 2. Find the time taken for the stone to reach its maximum height. Well, it starts with speed 8, and at its maximum height, its velocity will be 0. Acceleration is due to gravity. It's going up, so acceleration is minus 9.8. And we are interested in finding time. So 0 equals 8 minus 9.8t. 9.8t will equal 8. T is 8 divided by 9.8, which is, in our calculators, 40 over 49. Don't try and change this into a decimal. If you change answers into a decimal, you have to worry about 3 significant figures. Let's use 40 over 49. There's a number of ways to do part 2. I'm going to do the easiest way first. The stone was thrown vertically up with speed 8. It hits the cliff 5 seconds later. And because it initially travelled up, its acceleration is minus 9.8. We want to work out the displacement, so x will equal ut plus 1/2 a t squared. So that's 8 times 5 plus 1/2 times minus 9.8 times 5 squared, which is 25. And that gives us minus 82.5. Now the minus sign tells me that this is a distance below the starting point. So my stone has gone up and come down, and that tells me that the height of the cliff, is 82.5 metres. A lot of you in the exam wanted to work out the distance to the top, work out the distance from the top to the bottom, and subtract those to work out the height of the cliff. This is not my preferred method. It's a lot longer, and it leaves yourself open as you're doing a lot of calculations to lose marks for accuracy. If you're going to do this method, what my advice would be is to work out the time taken to get from the start back to the start. So that time is 2 times our 40 over 49. So that is 80 over 49. Again, this is where a lot of you were going wrong in the exam. You were using your decimal answer to part 1, which in most cases was rounded to 3 significant figures, but you're losing accuracy. You need to work to 4 significant figures, so you need the answer before you rounded it. So at the start, we'll be travelling at a speed of 8, because if we were released at 8, due to the symmetry of motion when we come down, we will be moving with a velocity of 8. So u is 8. Acceleration is 9.8, and it's plus 9.8 because we're working down. And time will be 5 minus 80 over 49. The time to go up, the time to come down. And that is 165 over 49. Remember, your Casio works in fractions, so use it. So this time again, I'm using S equals ut plus 1/2 a t squared. So that is 8 times 165 over 49 plus 1/2 times 9.8 times my 165 over 49 all squared. And I've just run out of a little bit of room there on the page. And that gives us 82.5 metres. Question 3, hardest question on the paper, a genuine last question of a past A-level paper. So it's a grade A question. Part 1, we're asked to draw a velocity time graph for the bus. So we have a bus passes A, travelling towards B at a constant velocity of 15. Maintains this for t seconds and then decelerates at a constant rate for the next 10. So that's t plus 10. That's our answer to part 1. You can't add any more to that. You've got to leave that for the examiner. If you want to use this graph in any way, then sketch it out again. Next part we're asked to do is find the deceleration. You'll see I've sketched my graph out again. Well, we start at 15. Our final velocity is 0. Remember, A stands for acceleration and T is 10. So V equals U plus AT. 0 equals 15 plus 10A. So 10A would be minus 15. A is minus 1.5. But we were asked in the question for the deceleration. So that is 1.5 metres per second squared. Distance travelled by the bus is the area of the graph, and if I draw it out, I'll see that it's trapezium. Length of this side is t plus 10, length of this side is t, and the distance in between is 15. So half the sum of the parallel sides times the distance between. Half times 2t plus 10 times 15. So half of 2 is 1 times 15, 15t. Half of 10 is 5, and 5 15s are 75. Now we have a second vehicle. It leaves after 5 seconds. it's going to arrive at the same time and it accelerates. Now if it starts at 5 and it goes to t plus 10, then this distance along the bottom is the t plus 10 minus 5. So it's travelling for t plus 5 seconds. We want to work out how far it's travelled. Normally I would use area, but in this case I'm going to use the formula. S equals ut plus a half a t squared. When u is 0, acceleration is 5 over 3, and I've just shown that time is t plus 5 all squared. So that's 5 over 6 t plus 5 all squared. Now I'm going to do a short aside at the moment. Can you please all be careful? This was answered very badly in the paper. T plus 5 all squared is the bracket t plus 5 times the bracket t plus 5. So t times t plus 5 gives us t squared plus 5t. And 5 times the bracket t plus 5 gives us 5t plus 25. So that's t squared plus 10t plus 25. A lot of you missed the 10t in the middle. So that gives us 5/6 t squared plus 10t plus 25. The two vehicles have to have travelled the same distance, so 5/6 of t squared plus 10t plus 25 has to equal 15t plus 75. Multiplying across by 6 and dividing by 5, so t squared plus 10t plus 25 equals 6 over 5 times 15t plus 75. 5 and 15 cancel to give 3, 5 and 75 cancel to give 15. So this gives us that t squared plus 10t plus 25 equals 18t plus 90. So t squared minus 8t minus 65 equals 0. And factorising that by whatever method you're most confident with, t minus 13, t plus 5 equals 0. So t equals 13 or t equals minus 5. Always include the two answers. Time can't be negative, so that's impossible. Let's just go back, read the question and check we've answered what's been asked for. And in this case, I haven't. I've asked for the distance, but I know that the time is 13. So the distance is 15t plus 75. So that's 15 times 13 plus 75. 270 metres. I'm going to show you one algebra way that you could have simplified this even further. The first distance that the bus travelled was 15t plus 75. If I hadn't have expanded the brackets, that would have been 15 upon t plus 5. The car we saw travelled for 5/6 upon t plus 5 all squared. If we put these two equal to one another, we have that 5/6 t plus 5 all squared equals 15. T plus 5, the 5 and the 15 cancel. And if we then multiply across by the 6, we get that t plus 5 all squared equals 18 upon t plus 5. So t plus 5 all squared minus 18 upon t plus 5 has to equal 0. That can be factorised. T plus 5 outside, inside a t plus 5 and a minus 18 have to equal 0. So we have that t plus 5 equals 0, which gives us the answer t equals minus 5. Or we have t plus 5 minus 18 equals 0, and we get t equals 13. This algebra method is not for everybody.